Hey class, this is chapter 2, section 2, talking about unit conversions. In this world, we convert things all the time. We go from $1 to €1, from pennies to a nickel, or from dollars to $100 bills. And so we're going to learn 3 steps on how to make conversion problems very easy to manage. Over the course of this year in chemistry, you're going to see conversion problems that have 2, 3, or even 5-step conversion factors needed to complete the answer successfully. So what we're going to see today is how to set up a conversion problem, and more importantly, we're really going to focus on how to get a conversion factor. So here are the 3 rules I want you to memorize on how to do conversion problems. 1, you're going to write down what you know. This is what's going to be given to you in the question. Number 2, you will follow your units. When we follow our units, we want it to be as if the problem if the unit from the original question gets canceled out by our conversion factor. And step 3, I'll show you how to get a conversion factor. And basically, those are fractions that we create based on equations when we know what equals what. And I'll show you what all this means here shortly. So a conversion factor. It's just a ratio of equivalent measurements, meaning when 2 things equal each other, they're the same. And when they're the same, we can turn them into a ratio or a fraction. Take, for example, 1 meter equals 100 centimeters. I will show you on the next slide how you can divide these by each other to come up with 2 ways of just writing the number 1. And remember, when you multiply any number in this world by 1, you still get the same number. So 1 million times 1 still equals 1 million. 5 million times 1 equals 5 million. So on this next screen, you will see a conversion factor. This will be my end result. I have the conversion factor of 1 meter over 100 centimeters equals 1. Let me show you how we come up with that number. First of all, we start with a true statement. It is a true statement that 1 meter equals 100 centimeters. You can find these on page 35 in your textbook, and you need to have these memorized by Friday as we will have a quiz. Now look back in your notes, and I shortened the number of prefixes you need to know in your notes, but page 35 has all the prefixes to help you answer these problems. So you start with a true statement, 1 meter equals 100 centimeters. Then I'm going to divide both sides by the same value. I'm going to choose to divide by 100 centimeters. When I divide by 100 centimeters, you will see on the right, this will get canceled out and become just a 1. Now I have my conversion factor. 1 meter over 100 centimeters is my conversion factor. This deals with step 3 in how we do conversion problems. So in the same way, if I go the other way, if I have 1 meter equals 100 centimeters and I divide by 1 meter, those will cancel out to show me that I can rewrite my conversion factor to where it says 100 centimeters over 1 meter. These 2 conversion factors both equal the value of 1. So if I multiply these by any number, that value will stay the same, but it will allow me to change my...
Custodian, please dial extension 11932. A custodian?
Sorry about that. So again, this just allows me to have a conversion factor. When 2 things equal each other, they can be rewritten in a fraction form that will help me answer conversion problems. So remember, it's just a unique way of writing the number 1. This does not change the value, it just changes the units. And so when we come to how to write, let's practice. Right now, press pause and take a second for you to write your own conversion factors. I am not looking for you to do all 3 steps. I am just looking for you to give me what fraction you would come up with where kilograms equals grams and where feet equals feet. Take a second to see if you can come up with your own conversion factors. So the answers I'd be looking for here would look a little something like this. Ooh, that's a little crazy. So I'm looking at 1 kilogram equals 100 grams, or 1 kilogram equals 1,000 grams, or 1,000 grams equals 1 kilogram. Likewise, my conversion factor would be 12 inches equals 1 foot, or 1 foot is 12 inches. You can see that. That's a little trippy. And this next part here on the bottom in writing these conversion factors is that now that you see whenever two things are equal to each other and you can determine a conversion factor, you can see things in this form to where now I can simply take 1 liter and I divide it by 1 decimeter cubed, and that is my new conversion factor. Or I could take 1 liter divided by 1,000 centimeters cubed, and that too can be a conversion factor. As you can see here in the examples of different conversion factors that I wrote. Now again, this is only how to address step 3 in our 3 steps to do a conversion problem. So now let's practice. We can multiply any number by a conversion factor to creatively change our units. So let's try it. If you have 13 inches, how many feet would that be? So what we want to do is we want to write down what we know. We would start by writing down 13 inches. Then we would multiply that by our conversion factor. Our conversion factor would need to have inches on the bottom. So that is what we call in following your units. So I'm going to write what I know. If I have inches here, I need to write inches here. And then I'm going to get step 3, my conversion factor. 1 foot over 12 inches gives me my conversion factor. The inches can cancel out, and I will successfully be able to take 13 divided by 12 and come up with 1.1 feet. That is a single step conversion problem. But what about if we have something where we don't know how to directly go from one unit to the next? We then need to use 2 conversion factors. So let's try it again. Now, if I have 13 inches, how many yards is that? Now, you could cheat, come up with one conversion factor where you know 36 inches equals 1 yard. But let's see what it looks like when I do it in 2 steps. So again, step 1 of what we're learning is I write down what I know. I know I have 13 inches. That is given to me in the problem right here. But now I'm going to follow my units. Step 2, I go inches to inches, and I know I can go from inches to feet. But since I want to get to yards and my answer will be in feet, I need to add 1 more conversion factor. So I repeat step 2. Step 2 is follow your units. So I take feet to feet, and then I know I can go from feet to yard. Step 3, get my conversion factors. I know for every 1 feet, that's 12 inches. And for every 1 yard, that's 3 yards. And that will successfully help me set up my problem on how to do conversion problems. We will practice this a lot more in class, but you really need to be committed to following the 3 steps I gave you and showing your work in this manner. As we get more into our chemistry and we learn more about units and how to convert between moles and atoms and beyond, it's really key that you know how to do this. Now, on your own, you can practice this problem. This is an example of some single conversion factors going from millimeters to meters and miles to feet. I went ahead and gave you the basis for your conversion factor from miles to feet. You can also practice these 4 problems. These are double conversion factors where you'll need to go from millimeters to meters and then from meters to nanometers with having 2 conversion factors. Same thing, you'll need to go from miles to feet, from feet to inches, from gallons to liters, from liters to milliliters. And then in the last problem, you should go from days to hours, from hours to minutes. Practice your work, and I'll answer your questions in class. I hope this helps for all those who are absent. Have a great day.